Good morning, guys. Welcome to my YouTube channel. This is lesson 3A-2. I'm going to do the exercises that are in red, and then I want you to try the ones that are in yellow afterwards. Make sure you pause the video if there's something you didn't understand and write down the question you have. We're going to start off by going a quick review. So on the first one, I have 1x plus 1x because the coefficient here, if there is no number, is a 1. So if I have an x and I have another x, in total I have 2 x's. On the second one, again, if there's no coefficient, we can always put a 1 in there. I have 1x and I owe 1x, so that cancels out and leaves me with 0. For the third one, I have x times x. We should be thinking the laws of exponents because we have the same base, x. And now I have an exponent of 1 with that one and an exponent of 1 with the other one. So what do? I keep the base, x, and I add the exponents. 1 plus 1, it gives me 2. 3, I have x divided by x. This is something I also showed you guys yesterday. If you have the same number on top and bottom, meaning numerator and denominator, it's going to cancel and leave you with 1. So here, if I have 1x divided by 1x, that gives me 1. And that's just a little review. You can see that based on what the operation is, we're going to do different things. If it's addition and subtraction, we need to have the same base and the same exponent to add and subtract the coefficients. If you're multiplying, again, we need the same base, and then we're going to add the exponents. So let's start off with the note that's at the bottom of your page. To multiply a monomial by a polynomial, blank the term in front of the parentheses to blank term in the parentheses. We're going to distribute the term in front of the parentheses to each term in the parentheses. You multiply the coefficients and add the exponents with like bases. We already know how to distribute, so it shouldn't be hard. The only extra step is that we're looking at the exponents. So for the first one, I have 3x times negative 2x. Again, I'm going to identify the coefficients, 3 and negative 2. I'm going to multiply them normally, and it gives me negative 6. And then I'm also multiplying the x with the other x. Well, I keep the base, and I add the exponents. The exponents on the first x is a 1, and on the second one is a 1. So I end up with negative 6x squared. On the second one, I have 6x squared. Remember that that's telling me that whatever's on the inside of the parentheses is being multiplied by itself twice. So this is actually 6x times 6x. Again, I can multiply the coefficients, in this case to 6, and I get 36. I keep the base or the variable, and I add the exponents. 1 and 1 gives me 2. The other way you could have done this one is the rule. Remember, when there's an external power, the 2, I'm going to write down my coefficient, 6. Oh, I don't know why I wrote negative 6. 6. I'm going to raise it to my external power. I'm going to write down the variable and just multiply the exponents. Remember here in this case, the exponent to the x is a 1, so 1 times 2 gives me 2. 6 squared is not 12. You put it in your calculator, it means 6 times 6, which is 36. So we have 36x squared. Let's look at number 5. Again, I see parentheses. That means I'm going to distribute whatever's in front, right? What's in front of my parentheses, in this case, is a 9k cubed. I'm going to distribute. And remember, when I distribute, I'm multiplying to everything on the inside. So I'm going to, again, multiply 9k cubed times 2k cubed. I multiply the two coefficients, so I have 9 times 2 gives me 18. I have a k cubed and a k squared. Same base, so I write down the k, and I'm going to add the exponents. K cubed times k squared gives me k to the 5th, because 3 plus 2 is 5. I'm also going to multiply the 9k cubed to the negative 4. Again, multiply the coefficients, which gives me negative 36. I'm going to keep the base of the variable, k cubed. Is there another k on that term? No, so I'm just going to write down k cubed. And that's really it. You can try the rest of the problems, and then you can check your answers tomorrow. To the next one. Okay, so this one's a little bit different, but again, if you have the same basic skills of being able to distribute and multiply and add the exponents, you should be fine. To multiply a polynomial by a polynomial, use the distributive property to multiply every term in the first set of parentheses with every term in the second set of parentheses. So if we look at 9, I have x minus 5 times x plus 2. From your first group of parentheses, I'm going to grab one of the terms. And what I'm going to do is multiply it to everything on the other polynomial. So I'm going to do x times x. When I'm multiplying x times x, remember I'm just keeping the base, adding the exponents, so I get x squared. Then I multiplied x times 2. When I multiply x times 2, I get positive 2x. I am also going to grab the other term, negative 5, and multiply it to everything on the other polynomial. So negative 5 times x gives me negative 5x. Negative 5 times 2 gives me negative 10. And now I'm going to see I have x squared plus 2x minus 5x minus 10x. You should see that the 2x and the negative 5x are common terms. We can add them because they have the same variable with the same exponent. So I just add the coefficients. 2x minus 5x gives me negative 3x. The x squared doesn't combine with anything else. There's no like term. And the negative 10 doesn't either, so I just write it down. Now this is a trinomial because it has 3 terms. First term x squared, second term negative 3x, third term negative 10. And if you want to use your vocabulary, this is also in standard form. How do I know it's in standard form? The exponents are going from greatest to least, right? They're descending. There's also another way you can do it. Whichever method works for you, you can do. For the other method, what I'm going to do is, it's called the box method. I have x minus 5, and I have x plus 2. I'm going to do a box like this. And what you're going to end up doing is we're multiplying within the box. I can't draw straight lines for my life. So what I'm going to do, to get the number that's going to go in here, or the variable with the exponent, I'm going to multiply the two things from that box. So x times x gives me x squared. To get what goes on this box, I'm going to multiply x times 2, right? I'm just always grabbing what's on that row and what's on that column. So x times 2 gives me 2x. To get what goes in this box, again, I'm multiplying what's on top, negative 5, and what's on the side, x. That gives me negative 5x. To get what goes in the last box, again, I'm multiplying negative 5 times 2, and that gives me negative 10. Now, you're always going to add what's on a diagonal, because those will always be what has the like terms. So I can write them down if you want. X squared minus 5x plus 2x minus 10. And again, you should see that the 5x and the 2x are common. They'll always be in the diagonal. And I'll have x squared minus 3x minus 10. So in either case, you get the same answer. Whichever method you prefer is the one you should try. I'm going to go with the first method, but you can do the second method as well. So you can try number 10. And I'll go on and do number 11. That one's slightly different, but not so much. So again, I'm grabbing each term and multiplying it to the other term. 3x is going to be multiplied to the x. I have a coefficient of 3 and a coefficient of 1. So again, I'm multiplying those coefficients and I get 3. I have a base of x with an exponent of 1 and an exponent of 1. So I get 2 as my new exponent. I'm going to multiply the 3x to the 5, and I get 15. There is no other x, so I'm just copying down the x. I'm also going to multiply the 2 to the other polynomial. 2 times x gives me positive 2x. 2 times 5 gives me positive 10. And again, I can combine like terms. These are like terms. So I end up with 3x squared plus 17x plus 10. That's really it. So the rest of the problems in here you should try. Again, if you have questions, write them down. Try 10 and 12. Let's look at number 13. I'll try 13. I'll do 13. And you'll do 14. Same idea. I'm going to grab a term on the polynomial, the first one, and multiply it to everything on the second. 2x times 2x. Again, multiply the coefficients, 2 and 2. I get 4. Keep the variable, or the base. And I'm going to add the exponents, right? Because we're multiplying. X times x gives me x squared. I'm also going to multiply the 2x to the y. Coefficient times coefficient. The coefficient with the y is a 1. So 2 times 1 is 2. There is no other x, so I'm just copying it down. And I also had a y, which I'm also just copying down. I'm also going to multiply 3y to everything on the other polynomial. 3y times 2x. Again, multiply the coefficients. 3 times 2 gives me positive 6. There is no other x and there is no other y, so I can just write them down. And it doesn't matter if I write xy or yx. They're still going to be common terms with the other one, right? What lets me switch the order between the variables xy or yx. Remember, the commutative property lets me do that. 3y times y. Coefficients 3 and 1 gives me 3. I have a y. I'm multiplying by another y, so what am I going to do? Just add the exponents, so I get y squared. When I combine like terms, I end up with 4x squared plus 8xy plus 3y squared. I'm going to only do number 15, and then I want you to try the rest of the problems in class and get as far as you can. So what does x plus 3 squared mean? Remember, this means this is an external power. This time, since I have a whole group of things that's being multiplied to itself, I have to write it out. So I'm going to write x plus 3 times x plus 3. And now it's similar to the other problem. I'm going to grab one term of the polynomial and multiply it to everything on the other. X times x gives me x squared. X times 3 gives me positive 3x. 3 times x gives me positive 3x. 3 times 3 gives me positive 9. When I combine like terms, you should end up with x squared plus 6x plus 9 as your answer. So the only other extra step here was, because we have a polynomial that's not only one term, right? This in particular is a binomial. I need to write it out twice because I need to make sure I'm multiplying each term from the polynomial to the other. Lastly, I want to show you how to do a problem like 19. Again, it's the same idea. I'm going to grab the first term and multiply it to each of the other ones. You just have multiple terms here. So w times w squared. Again, keep the base, w, add the exponents, and I get 3. W times negative 5w, multiply the coefficients first. Coefficient of 1 and a coefficient of negative 5, so I have negative 5. Again, I have like common bases, so I'm writing down the w and adding the exponents. I have an exponent of 1 and an exponent of 1, so I have w squared. I'm also going to multiply it to the third term. You're just multiplying to everything. So w times 1 just gives me a positive w. I'm also going to grab the negative 5 and multiply it to everything. Negative 5 times w squared gives me negative 5w squared. Negative 5 times negative 5w, multiply the coefficients. Negative 5 times negative 5 gives me positive 25. The w doesn't have anything to multiply with, so I just write it down. Negative 5 times 1 gives me negative 5. Now again, I'm going to look to combine like terms. I have a negative 5w squared and negative 5w squared. Remember, when we're adding and subtracting, it has to have the same variable and the same exponent in order for us to combine. So the w cubed didn't combine with anything. And then I have negative 5w squared. Negative 5w squared gives me negative 10w squared. The w combines with the 25w to give me positive 26w. And we just bring down the negative 5 because that doesn't combine with anything. And we're done. So I hope that now you take the time to do the rest of the exercises so you are prepared for tomorrow. Write down any questions you might have, and then the homework is on Unified Classroom. Bye.